Welcome to EDU World Space.
Problem 34.28 gives us an object distance of 16 centimeter from a thin lens, and we're told that the image is on the same side of the object with a distance of 12 centimeters. And in part A, we're asked to find the focal length of this lens and whether or not it's a diverging or converging lens. In part B, we're to find the image height given the object height, and we're asked whether or not it's an erect or inverted image. And finally, in part C, we are to draw the principal ray diagram for this lens with the object and the image. So let's do part A first. But before doing so, let me draw attention to why I wrote this as the absolute value of S. So we're told that the image is on the same side of the object, which means that the image distance S prime should be negative. So therefore, S prime is actually minus 12 centimeters. Because if S prime is on the same side as the object and the object is positive, that means that the incoming light is on, that S is on the side of the incoming light, or the side of the lens from which the light is incoming. And if S prime is on the side of the incoming light, then it is negative. If it's on the side of the outgoing light, or the side of the lens where you have the outgoing light, then it's positive. So this was the sign convention that was set up earlier in the chapter. So let's move on to solve part A. We will use equation 34.16, which is 1 over S plus 1 over S prime is equal to 1 over F. And if we do a bit of rearranging, we have S prime plus S over S prime times S is equal to 1 over F. And this means that S prime S over S prime plus S is equal to F. And we know S and S prime, so we can easily find F. So S prime is negative 12 centimeters. S is 16 centimeters. Again, divided by negative 12 centimeters plus 16 centimeters. And this gives us negative 48 centimeters as the focal length. Notice that the focal length is negative. So F is less than 0. And when the focal length is negative, the chapter tells us that this is a diverging lens. Now let's do part B. So we're given the height of the object as 8.5 millimeters. And we want to find the height of the image. So let's use equation 34.17, which tells us that the magnification is the image distance over the object distance. And we'll also make use of M is equal to Y primed over Y. But for now, let's focus on this part of the equation. So M is equal to negative 12 centimeters over 16 centimeters, and that's positive 0.75. So here we have the magnification, and now let's use the second part of the equation. So let me just write this over here. If I rearrange a little bit, that tells me that y prime is equal to m times y. So then y prime is equal to 0.75 times 8.5 millimeters, which gives me 6.38 millimeters. And I would urge you to plug in the numbers, of course, and check for yourself, just in case I made any mistakes. But the equations themselves and the method that I use should be correct. So now we're asked if the image is erect or inverted. And so since m is positive, then the image is erect. Now for part C, we'll draw the principal ray diagram. Okay, so we know we have, let me draw the optic axis, and we have a diverging lens, so I'll do my best to draw some straight lines, although I might have some issues. So we can label the focal length. Let's put the object somewhere over here, and then see where the image falls. So I guess I'll use the red one. So imagine that I have a straight line going through the center there. So this will continue undeflected here. So that gives me one line. And if I have, for example, a ray that's parallel to the optic axis, so imagine that this ray is parallel to the optic axis, it will diverge as if the light was coming from, kind of got cut off there, but this should be a straight line. It will diverge going this way. And that gives me enough points actually to draw in my object, because I have the intersection here. So the intersection of these two rays gives me the object. Additionally, you could have drawn another principal ray, one that's headed towards this second focal length over here. Let's see if I can do that. If I get it just right. So imagine that this one is headed over here. Well, that will go parallel to the optic axis, and then I extend it back, and again it should, if I drew everything right, it should actually intersect at the same point, but my lines weren't exactly straight, so it didn't intersect at this point, but it should have gone there. So this is our principal ray diagram.